Hi, I'm Lisandro Mathers, the Head of Sales and Marketing at Enhancements and the General Manager of Enhancements Latin America. And today I will show you what's new in version 4.3.0 of HELYX and ELEMENTS, Enhancements open source CFD solutions. In case you still don't know Enhancements and our products, let me quickly present it to you, and if you do, feel free to skip this part. Enhancements is a private company that develops CFD software using open source technology and also offers a range of services including consultancy, custom CFD code development, HPC on demand, and training. HELYX is our general purpose open source CFD solution, and it's used by more than 200 companies worldwide. Elements is our open source CFD software tailored for automotive design, external vehicle aerodynamics analysis, thermal design, and other general vehicle flow design applications. Both HELYX and ELEMENTS offer a wide range of CFD capabilities, such as high quality and automatic mesh generation through a fully parallel workflow, steady and transient flows, incompressible and compressible flow regimes, thermal analysis including natural and forced convection, radiation modeling, conjugate heat transfer, a very complete range of turbulence modeling models, including runs, unsteady runs, LES and DES, moving parts through different dynamic mesh approaches and immersive boundary methods, modeling capabilities for moving parts through the use of source terms such as MRF and GRF, advanced boundary conditions such as cyclic, periodic, and discrete mixing plane, acoustic analysis, including methods such as Proudman sources, Fox-Wheaton-Hawkins, or the Kirchhoff variation, multiphase flows both through VOF and Euler-Euler approaches, sea keeping, calm water resistance, self-propulsion and other naval and marine applications, and many other solvers, models, methods, and pre- and post-processing features. One of the main reasons for HELYX and ELEMENTS success is their open source nature. It means that all HELYX and ELEMENTS customers can fully access their source code and also benefit from the unlimited scalability of their licenses. Unlimited scalability means that you, as a CFD user, can run as many simultaneous simulations in as many computer cores as you have available, without the need to acquire extra HPC licenses. And basically, that's why Enhancements was built for, to enable you to create radically transformative solutions through the use of open source, scalable computational fluid dynamics and optimization software. This version 4.3.0 of HELYX and ELEMENTS brings the following main features: new dynamic multi-motion library, non-conformal coupling interfaces for both static and dynamic meshes, consolidation of the unified solver framework, firstly introduced in version 4, by incorporating the legacy multiphase flow solvers and models within the USF, and a new branding and visual identity of our company and products. In version 4, we introduced the concept of reference frames that was limited to a few solver components. Now, in version 4.3.0, we incorporated the concept of reference frames for nearly everything that can be done in HELYX and ELEMENTS, including geometry manipulation and mesh generation. In terms of the geometry tab, any transformation to geometry surfaces can be applied with respect to the standard global reference frame or to a user-defined local reference frame. Each separate geometry surface available in the Geometry tab can make use of a different local reference frame for easy alignment or replacement for example, parametric studies. Still, with respect to the Geometry tab, the CAD reader was completely refactored based on the Open Cascade library. This refactoring provides up to 100 times faster reading than the previous version, and more accurate and reliable surface representation of the original CAD file. In terms of mesh generation, we improved the interface for adding near-wall prism layers by adding the option of setting up the maximum layer thickness and final layer thickness in terms of both absolute or relative sizing, and by adding a new target expansion parameter to adjust the number of layers to match the desired growth ratio. We also improved the quality of near wall layers by adding a new option called Extrude Merge Ground Up, which merges cells on ground up patches, avoiding low quality issues due to having cells with more than one boundary face. Still in the mesh side, we refactored the direct feature snapping algorithm to improve accuracy on region boundaries, as you can see in the image comparing the previous and the current version. This improvement is particularly crucial for cases using mesh interfaces through AMI or NCC methods. In version 4.2.0, we introduced a new method called NCC, standing for Non-Conformal Coupling, used for mesh interfaces, which presents accuracy and mass conservation benefits over the traditional AMI method present in HELYX and ELEMENTS. In the previous version, the NCC method was limited to static mesh interfaces only. Now, in version 4.3.0, we extended the NCC to dynamic mesh interfaces as well, allowing the same boundary conditions available for AMI interfaces, such as cyclic, periodic cyclic, and discrete mixing plane boundary conditions. Also in the previous versions, we introduced the concept of reference frames, allowing the user to set up local coordinate systems for some methods in HELYX and ELEMENTS. In version 4.3.0, we completely refactored the mesh motion library, and now the user can make use of local reference frames for nearly any feature available in HELYX and ELEMENTS, from pre-processing to post-processing. In addition to that, multiple motion frames can be combined into the same model, allowing an easy setup of quite complex simulations in terms of motion. In terms of boundary conditions, we added a new runs atmospheric boundary condition for homogeneity atmospheric boundary layer flows. With respect to our mapped field boundary condition, users can now map velocity profiles from other boundaries while keeping the flow rate constant. In previous versions, users could only specify an average velocity vector. We added a new graphical user interface for semi-permeable membrane boundary condition, applicable for simulating species transport of multi-region cases. Users can control the mass flux across the membrane boundary for each species selectively. We also added a new time-varying size of cell zones containing scalar semi-implicit sources. The user can specify a vector function which dynamically activates or deactivates existing cell zone cells, which enhances, for example, the representation of fire smoke analysis. Finally, in terms of turbulence modeling, we extended the existing Y-Reynolds θ-T transition turbulence model to include cross-flow transition effects. We have now incorporated most multiphase flow solvers and models within the unified solver framework. All multiphase flow functionalities available in HELYX and ELEMENTS graphical user interface are now part of the unified solver framework. The new multiphase flow solver refactored in this version 4.3.0 can deal with compressibility of phases, buoyancy effects, adaptive mesh refinement, mesh motion, and multi-region CHT. As an example, in the left animation we can see a multiphase flow simulation using the VOF approach combined with adaptive mesh refinement and mesh motion using the NCC mesh interface method. In the right animation, we can see a CHT analysis of a hot sphere being cooled down by a cold water stream injected into air, also using the VOF approach. The Euler-Euler solver was also completely refactored in version 4.3.0, and the following models are available: interface drag, virtual mass, surface tension, interface compression, and heat transfer. Also, we refactored the graphical user interface to provide a much more comprehensive user experience. Finally, HELYX and ELEMENTS provide a function object to specifically calculate the performance of turbomachinery equipment. Previously, such function object was limited to pumps only, but in version 4.3.0 we have refactored and extended it to support additional turbomachinery equipment such as hydraulic reaction turbines, fans, compressors, and gas turbines. Reference frames are now available to view objects for visualization purposes, such as slices, clips, and so on. As an example, both animations show the same simulation of a fan rotating with dynamic mesh. However, the left animation is visualizing the results from the global reference frame, while the right one is the visualization from a reference frame attached to the fan blade surfaces. We also included support for animation creation directly from HELYX and ELEMENTS graphical user interfaces. Animations can be created by using existing scenes via runtime visualization during sober execution, via scene export, or on the fly by reading from a list of indexed images. Finally, we introduced a new image format type called EDF, available in runtime visualization, allowing for dynamic color bar ranges by saving different fields data in the EDF image rather than saving only the RGB color information. This is quite useful for use with our runtime visualization tool, since in previous versions the users needed to know a priori the scale in which they wanted to save the images, resulting in a non-ideal scale for assessing the results. Now, they can dynamically change the scale after the images are generated, eliminating such a limitation. In order to visualize such images, we have introduced a specific EDF image editor. This is in beta version and users can find its executable in HELYX installation folder. In previous version 4.2.0, we introduced a new adaptive relaxation option in our coupled solver to speed up convergence as an alternative option with respect to the existing pseudo timestamp approach. In this version 4.3.0, we have incorporated full graphical user interface support for such a feature. With respect to the HELYX Marine add-on, we incorporated all HELYX Marine solvers to the multiphase flow unified solver framework. The graphical user interface offers the LFS and the VOF Marine solvers with improved runtimes and reviewed best practices for both planning and placement hosts. We also included interfaces for calm water resistance and sea keeping analysis through the use of our custom graphical user interface components available in our macro library. In previous versions of Elements, users could make a template for the wind tunnel which had 5-belt moving ground system. However, there was no mechanism to automatically move the wheel pads when importing geometry with different wheelbase. In such a case, one would need to recreate all the floor patches. In version 4.3.0 of Elements, users can now achieve that using the configuration files of Elements IO Wizard. Another feature added to Elements is the ability to use same volume refinements with different vehicles to achieve consistent meshing. In summary, this version 4.3.0 of HELYX and Elements is mainly about consolidation of the USF by incorporating the multiphase flow solvers within such a framework, providing to you a much more flexible, comprehensive, and multi-physics CFD software platform. Our customers can already download HELYX and Elements version 4.3.0 in our customer portal, and if you are not a customer but want to learn more about HELYX and Elements, feel free to contact us at our website, or you can always reach out to anyone from Angel's team through LinkedIn. We will be more than happy to talk about CFD with you. Thank you, and I see you in the next HELYX and Elements release.